Hello students, this is Mr. Steigerwald. Today we're going to be taking notes on lesson 9.6, Dilations. Dilations is the fourth transformation that we're going to be talking about in this section here. Our objectives are to use dilations and proportions to solve world problems, and to draw dilations in the coordinate plane. Vocabulary? Actually, we already had it on the first day. When we talked about dilations, we talked about how an object can get bigger or smaller. So we talked about its size. Let's go to the top here so that we can look at the Common Core standards. And if you need to pause, go ahead and do so. Identifying dilations. We're going to tell whether each transformation appears to be a dilation. Go ahead and write this down now. If A, B, C, or D is a dilation, you can just write yes or no. And when you're done, turn this back on. A is not a dilation. B is a dilation. C is not a dilation. D is a dilation. Beep. All right, in the upper right-hand corner, go ahead and write this down. A dilation enlarges or reduces all dimension proportionally. A dilation with a scale factor greater than 1 is an enlargement or expansion. A dilation with a scale factor greater than 0 but less than 1 is a reduction or contraction. Beep. All right, on to application example. On a sketch of a flower, 4 inches represents 1 inch on the actual flower. If the flower has a 3-inch diameter in the sketch, find the diameter of the actual flower. Now below you'll see a sketch of an actual flower. And you see that the diameter is 3 inches. What is the length of the diameter of the actual flower? And this is how we're going to set it up. When we read back in the application, it says on a sketch of a flower, 4 inches represents 1 inch. Okay, so we're going from sketch to the actual. So I'm going to put a little S over A to remind myself that the number on top is related to the sketch, and the A on the number on the bottom is going to be the actual. So we have 4 inches on the sketch represents 1 inch on the actual flower. So I'm going to put 4 over 1 equals. Now on the right hand side, it states that if the flower has a 3-inch diameter in the sketch, that 3 is going to go on top of the fraction on the right hand side. Find the diameter of the actual flower. Well, we don't know what that's going to be, so we're going to put an X there. And as we did in the other chapter, what we're going to do is we're going to go ahead and cross multiply. 4 times x is 4x, and that's going to equal to 1 times 3 is 3. Divide both sides by 4, and our x is going to equal 0.75. The diameter of the actual flower is going to be 0.75 inches, 3/4 of an inch. Go ahead and write that sentence down. And when you're done with that, go on to the next slide. Beep. What if? An artist is creating a large painting from a photograph. The artist divides the photograph into squares and dilates each square by a factor of 4. Suppose the photograph is a square with sides of length 10 inches. Find the area of the painting. And I tell you what, this is what I want you to do. I want you to go ahead and draw that diagram, and then I want you to find the area of the painting. Remember, area is going to be height times length, length times width. Go ahead and do that. And when you're done, go ahead and hit the pause button to restart this video. Beep. All right. With that problem that you just did, we're going to check your answer tomorrow in class. Let's go on to the next problem. Drawing dilations in the coordinate plane. Draw the image of the triangle with vertices P, Q, and R, with the ordered pairs that are given, under a dilation with a scale factor of 1/2 centered at the origin. Go ahead and plot your points, and go ahead and start the table off to the right side of the coordinate plane. Hit pause, and when you're done, unpause it. All right. The center is going to be at the origin. And remember, the origin is located right here where that red dot is. Now, we're going to dilate this by 1/2. We're going to actually make this triangle here smaller. And how are we going to do it graphically? Well, from the center to that point P, you see that is here's 1, 2, 3, 4 diagonal units from the center. If we want to go halfway, this is where, since our dilation is 1/2, where I put that big red dot, that is going to be our new P prime. So what we're going to do is we're going to cut that distance in half. If you look at our Q, you see that it is 1, 2 diagonal units from the center. So we're going to cut that in half, the distance in half. So 1 diagonal unit is going to be right here from the center. And we're going to call that Q prime. From our R, you see that this is 1, 2, 3, 4 units from our center. So let's count out 2 units from the center. 1, 2. And where I put that next red dot, that is going to be R prime. Go ahead and connect those points. I'm going to do it with black so that you can see that. Let's see if I could get rid of these red lines here, because we don't need those. Let's put our points back up here. Let me erase this. There. That black triangle right there, we just dilated triangle PQR to triangle P prime, Q prime, and R prime. Now, how are we going to do this with the table? Well, we're just going to take half of each ordered pair, meaning this. With our x value, I want to do this in red, so whoops, let me erase that. With our x value, we're just going to multiply it by, what's the scale factor? 1/2. So we're going to multiply it by 1/2. Our y, we're going to multiply that by 1/2. And we're going to do it for each point. So half of -4 is going to be -2. Half of 4 is 2. That's the ordered pair for P prime. Do the same thing for your Q and your R. Go ahead and pause this and then check your answer. Our Q prime, half of -2 is -1. Half of the other -2 is -1. And for our R, it's going to become R prime after We dilate it with a scale factor of 1/2. Half of 4 is 2. Half of 0 is 0. That there will be our new order pairs for our P prime, our Q prime, and R prime. We'll see you tomorrow in class. Bye.